Hi folks, welcome back to part 4 of section 5.2, the definite integral. So we're going to finish up this section with the average value theorem for integrals. And so we're going to start with a picture like we started with a lot of these sections, and we're going to take a look at some questions. So, example 8. If region 1 is the triangle, so let's go ahead and highlight that triangle. So if region 1 is this triangle, then part A says find the area of region 1. Well, this is definitely a case where I would use geometry. So I can say the area of this triangle is 1/2. The base is 2 and the height is 5. So that point up there is at 5. And so if I reduce the 2 and the 1/2, I end up with an area of 5. Okay? Not too bad. All right. Part B says draw a rectangle that has the same length along the x-axis as region 1 and has the same area as region 1. So I want to think about this. An area of a rectangle is length times width. Now I want that area to equal 5, but the length has to be 2 because that's the distance across the x-axis. So 2 times w equals 5, or let's use h for height, length times height. And so h is going to equal 5 divided by 2, or 2.5. This is the y value of that rectangle. And I'm going to go ahead and erase the triangle that I highlighted here. And we're going to go ahead instead and we're going to draw the rectangle that has that same height. And so if I draw it on here, this part is the same. I'm going to go up to 2.5. And so this purple rectangle that I'm drawing right now has the same area as region 1, and the height is what we found here at 2.5. Okay? All right. So this last part, part C, says using calculus notation and algebraic notation, write a mathematical expression that represents the equality of your answers from parts A and B. And so when we think about that, what we're doing is saying those two things are equal. So let's call this function f of x. And so if I want to say part A, another way to say part A would have been the integral from 0 to 2 of f of x dx. I don't know the function, but that's okay. I can leave it as f of x. And that equals, what did that equal? It equaled the 2, or the length, so 2 minus 0, which is our top and bottom bounds, that's not a coincidence, times a certain y value. Okay? Now, this will keep like this for right now, but as we go through the other examples, we're going to start to modify this notation because it actually will give us the formula for this average value theorem. Okay? All right, example 9. If region 2 is the trapezoid, find the following. So let me go back and highlight the trapezoid, and let's use orange. So my trapezoid looks like this, okay? And that area, let's see, area of a trapezoid is going to be 1/2 base 1 plus base 2 times the height. So let me go back to my graph. Base 1 is from 2 to 7, so that is 5 units. All right. Base 2 is from 3 to 6, so that's 3 units. So 5 and 3, and the height is 4. So 5 and 3 times 4, which will give me 2 times 8, which is 16. Okay, so my goal now is to draw a rectangle that has the same length along the x-axis and has the same area as region 2. So let's start the same way. Area equals length times height, which I want to equal 16. Length is going to be 7 minus 2 times the height, and that's going to equal 16. And so my height will equal 16 over 5. Or just because we're going to graph that, let's turn that into a decimal and see what it is. So 16 divided by 5 will give me about 3.2. Now, because this is a negative area, because it's below the curve, this height is going to be a negative 3.2. So if I do the same thing again, I'm going to erase my trapezoid, erase that part. And in orange, I'm going to go ahead and draw that rectangle. So that's the length of my rectangle. It's going to go down to about 3.2, so like somewhere there. And if I find the area of this rectangle, it will be the same as the area of the trapezoid. Okay, so let's use that calculus notation. Part A, we could say as the integral from 2 to 7 of f of x dx. And that equals 7 minus 2 times a given y value. Okay? Now I'm purposely leaving 7 minus 2 as 7 minus 2. I know it's 5. I know that you know it's 5. But the important thing here is that 2 is that number. The bottom bound is 2, and 7 is the first number. Okay? All right, last one. Example 10. If region 3 is the semicircle, we're going to answer the same question. So let's go back up to the graph. And I'm going to do the semicircle in a green color. So I've got this semicircle right here. Okay, and this one's going to be a positive area. And while we're here, let's just write down the radius so we don't need to come back in and count it. So this radius looks to be 3 for my semicircle. Okay. So find the area. Area equals 1/2 pi 3 squared, or 9 pi over 2. And we're going to leave it like that for right now, okay? But we'll turn it into a decimal when we need help graphing. So draw a rectangle that has the same length as along the x-axis as region 1 and has the same area. So we want the area of that rectangle, which will equal length times height, to equal 9 pi over 2. Now our length is going to be 13 minus 7 times the height, which is 9 pi over 2. And that gives us 6h equals 9 pi over 2, which gives us h equals 9 pi over 12, or we could say that's 3 pi over 4. But since we're graphing it, let's turn that into a decimal, which gives us about 2.356. Okay? So when I go back up to my diagram, I'm going to draw a height of a rectangle about 2.3. Okay, so let's get rid of this semicircle drawing, but in the same color. Let's see what the height would be. So 7 to 13, and I'm going to go up 2.3 about, oh, that's not 2.3. 2 is up here, so 0.3 is about here. Okay, so the green rectangle that I've drawn has the same area as that semicircle does. Okay, so how do we use calculus notation to write that? Well, part A would be the integral from 7 to 13 of f of x dx equals 13 minus 7 times some y value. Okay? Now, this average value theorem, all right, so let's scroll back up for a moment. Average value theorem, here's what you'll find if you look in any textbook. Okay? If you look in any textbook, the average value theorem for integrals will tell you this, that c equals 1 over b minus a, the integral from a to b of f of x dx. All right? This is exactly what we've done in the last few parts. The only difference is this y value, they left it all by itself. So if I go back up to this example with the semicircle, how do I get this y value by itself? Well, I divide by 13 minus 7. And if I go back up to example 9, how do I get this y value by itself? Well, I divide by 7 minus 2. And if I go back to the original one, how do I get this y value by itself? I divide by 2 minus 0. And so in its general form, we can say that we can find that average value by following this formula. 1 over b minus a times the integral from a to b of f of x dx. Okay? You really want to read the problems carefully. They'll say find the average value. Then you need to divide by the b minus a. All right? And all that does is it gives you the y value of a rectangle that has the same area as the region being looked at. Okay? So whatever region you're studying, if you want to find the average value, then you plug things into this formula. It will give you how tall is that rectangle that has the same area as the region you want. Okay? So that's it for 5.2. Thanks for making it all the way through. And if you have any questions, send me a message on Canvas or email me or on WebAssign, and I'm happy to help you out. All right, thanks so much, folks. See you later.